Polynomial functions of degree n. If the graph is a polynomial function, then the graph is smooth, continuous, and no sharp corners. Continuous means it doesn't have any breaks. Smooth, it means it's not jagged. And no sharp corners will be like jagged also. So let's talk about the degree, since that's going to give us a lot of information. The degree of this polynomial is 1. N equal 1. We're going to use n to represent the degree. So the degree is found, the power is found in that term where you have the biggest power on the variable. So this is x to the first. That's the biggest power on the variable. Notice we have here more than one variable, but the one that has the biggest power, that's the degree. So the degree of this polynomial is 2, n equal 2. The degree of this polynomial is 4. That's the biggest power on the variable. So n equal 4. Reading polynomial graphs. So notice these two go together. Both of them have an even degree. These go together. Both of them have an odd degree. If the polynomial has an even degree, you expect it at the ends, the end behavior, to be in the same direction, if it's even. If it's an odd degree, then it should be pointing in opposite directions. Now, if you go back to the sign in front of x to the second, it's a plus. So we expect this polynomial to be opening up. But the end behavior is up. This one has a negative in front of x to the second. So the end behavior, both branches are pointing down. For the odds, if it has a positive coefficient, which is the number in front of x to the third, then it falls to the left and rises to the right. If it has a negative coefficient, which is the number in front of x to the third, then it rises to the left and falls to the right. If n is the degree, then if the degree is odd, the end behavior is in opposite directions. We also should know something else. So once you know the degree, then this is what you could expect. The number of x-intercepts is at most n. Remember where the n is the degree, at most, and it shouldn't exceed that number, the number of x-intercepts. The number of turning points, which are the max and mins, the lows and highs, should be at most n minus 1. In other words, the number of turning points shouldn't exceed n minus 1. Polynomial profile. So again, we're describing a polynomial. This time it's an even degree. If n is the degree, then if it's an even degree, the end behavior of both rising at the end, or they're both falling. Right here at the end, they're both rising. Right here at the end, they're both falling. Also, this one has the same requirement as odd degree. Once you know the degree, then the number of x-intercepts is at most n. It cannot exceed n. Whatever the degree is, the number of x-intercepts shouldn't be greater than that. And the number of turning points at most should be n minus 1. That means the number of turning points shouldn't be above n minus 1. Let's practice with this polynomial. State whether the graph could be possibly the graph of some polynomial function. It could be. The answer is yes, because it's smooth, continuous, and no sharp corners. So it could possibly be some polynomial function. Can this possibly be a polynomial of degree 3? Well, if you look at it, it's at the ends, it's pointing in opposite direction. So it seems like it is. It could possibly be a degree 3. But we now have to meet the other two requirements, the x-intercept requirement and the turning points. So this polynomial that might be a degree 3, does it have at most 3 x-intercepts? 1, 2, 3, 4, 5. It doesn't. So even though it was going to be a polynomial of degree 3, since it doesn't have the correct number of x-intercepts, it cannot possibly be a degree 3 polynomial. Can this be a polynomial of degree 4? Well, right off the top is no, because degree 4 polynomials should have the ends pointing in the same direction. So this one is disqualified right away. Can this be a polynomial of degree 5? Okay, it's odd. It's pointing opposite directions at the end. So now let's go through the other two requirements. Does it have at the most 5 x-intercepts? 1, 2, 3, 4, 5. Yes. It doesn't go above 5 x-intercepts. Does it have at the most n minus 1 turning points? That would be 4. 1, 2, 3, 4. So it didn't go above 4 turning points. So yes, this could possibly be a polynomial of degree 5. So this is a summary of what we just said. For a final yes, you need to confirm number of x-intercepts and the number of turning points to have a final yes.